So in this video, we are going to see the equation 2 of the Westmark, and it is on projectile motions. So we are given a ball is kicked from horizontal ground towards a vertical wall as shown in figure, so that the horizontal distance initial position of the ball and the base of the height is 24 meters. The ball is kicked at an initially at speed of v at an angle of 28 degrees to the horizontal. The ball hit the top of the wall after 1.5 seconds. Calculate the initial component of the speed v. Calculate the initial component of the speed vx of the ball. Okay, now let us move straight to the solution. Now you apply it. You see that this is now the scenario that I'm trying to draw to scale. It's really not good. So we have seen that they're asking. So when you talk of projectile motion, this is what you have to just jot from your mind. That ax equals 0 meters per second. So acceleration in the x direction is always 0 for a projectile. Acceleration in the y direction is negative 9.8 meters per second square. If we are taking acceleration is to bring things down, so upward is counteracted, so it should be negative. Then v equals to u plus at, v squared equals to u squared plus 2ad, s equals to ut plus half at squared. These are equations of motion that you know since Form 5. Okay, now and this equation applied in x and y direction. If you are taking vx here, it will be ux, it will be ax. Time is a scalar, has no direction. If you apply it to the y direction, the velocity will be vy, uy, ay at the same thing. But ax is 0, ay is negative 9.8. So now you come to the first part that tells to calculate the horizontal component of the velocity vx of the ball. So to calculate that, we now therefore give us the horizontal displacement. I can now say that the horizontal distance dx will be equal to, this is the equation that have this one and this one. So now use x here supposed to be d. So we now get dx equals to uxt plus half into axt squared. Okay, now if you substitute now ax to be 0 from here, then you just get your dx equals to uxt, and your dx on t equals to ux. So dx on t will be 24 meters on 3 on 2, or 1.5 seconds, and that gives you 16 meters per second. So that is your speed in the x direction. Now they ask us to calculate the time taken for the ball to reach its maximum height above the ground. Well, at maximum height, the ball will normally be going up now. That is, at maximum height, the ball is just to come down. So at maximum height, speed in the y direction, that is the speed with which the ball is increasing upward, will be 0. So we can now come and multiply the y direction. You know that vy equals to uy plus ayt using the first equation of motion. And now if you substitute now, your final speed will be 0. Uy is simply the speed in the y direction plus ayt h, that is at maximum height. Now your maximum height will be negative uy on ay, and that will be negative uy. We just calculated it to be 8.51 meters per second, all on negative 9.81 meters per second. I get th to be 0.87. Anyway, this way I calculated the vy. I know that vx is equal to v cos theta by resolving this speed in the horizontal component, which is my pen, in the horizontal component and its vertical component. So you get vx to be v cos 28, and that one will be v sine 28 for the vertical component. Now if you come here, you say that vx that you have already had here, 16, will now be equals to what? V cos theta, and your theta is what? 28. So 16. So you can divide now both sides by cos theta to get 16 meters per second cos 28 equals to v, and your v will be 18.12 meters per second. And now from there we know that vy is equals to v sin theta. Now that we already have our v using the vx, we can go ahead and get our vy or uy, v in the initial speed in the y direction. So uy equals to v sin theta. So vy is equals to 18.2 sin 28. We get 8.51. So this is the time that I've just come here and substitute in this nice equation, and I got, so the acceleration is going, the ball is going upward, it is against gravity. That's why we substitute the acceleration to be negative. So we have 0.87 seconds. So that is the time the ball took to, and it is reasonably correct. See, the ball is taken from here to here. Here it did not reach the ground. Had it been the ball going like this, then there will be a symmetry. The time from here to here will be the time from here, but the ball ended here, means this time from here to here should be greater than the time from here to here. So if you take 1.5 minus 0.8, you get a value that is 1.5 over 2 is less than 0. It means that the rest of the time the ball took to go this way. Don't say you want to resolve time. Time is a scalar quantity. Don't say you want to say the time. Anyway, I'm sure you understand. Okay, now let us say they are saying that you should calculate the distance, the vertical height at maximum height for the C part. Now for the maximum height, I can use now the second equation. So v square in the y direction equals to that same thing again in the maximum direction. The speed in the y direction will be 0. That will be equals to uy squared plus 2a dy, and dy now is our maximum height. That is, we are applying this equation, this one, since these are the two that have time, have distance, so we can use the other one that have the maximum time. So we now move and we get our negative u squared y over 2 dy, and dy will now be equals to negative into 8.42 into negative 9.8, and we get 3.69 meters. So that is the maximum height attained by the ball. I think that is that for this question. So I wish you the best for your examination. So you can post, and each time I take screenshots, it is allowed. Thanks for watching. Have a great day.